The French River is probably one of the most iconic rivers in Canada. It was the first river to actually gain heritage status, Canadian heritage status, and it's been used for centuries to millennia.
The landscape around Georgian Bay is covered by forests, lakes, open rock, and peat wetlands. Many species call this area home, including some of Canada's reptiles at risk.
So on the rock-barren landscape, turtles nest in shallow soil deposits, a couple centimeters at the very least. If it's a smaller turtle, maybe 5 centimeters, and it can be up to 20 centimeters that a larger species might use.
Other reptiles, like Ontario's only venomous snake, the Massasauga rattlesnake, utilizes peat wetlands found in this landscape. But what do I mean by peat?
So peat is partially decomposed organic matter, and it accumulates over 40 centimeters in Canada. We call that a peatland. Northern peatlands store about 500 gigatons. That's 500 times 10 to the 15 grams of carbon. That's the equivalent of about 50 to 60 years of fossil fuel emissions.
Yeah, so the thing about peatlands is that usually throughout a lot of the year they have a water table which is quite high to their ground surface. But then in the summer or in periods of drought, that water table decreases. If that drying continues, the water table can drop all the way down to the bottom of the peatland, and that's when it really becomes very vulnerable to wildfire.
The Parry Sound 33 fire burned over 11,000 hectares. It started on July 18th of 2018. And it wasn't officially out until Halloween of that year, so almost 3.5 months of burning. One of the reasons why we believe it burned so long was it got into and burned deeply into peat deposits. And as a result, there's very likely there was a very large carbon loss to the atmosphere from this fire. But it's very rare to have a large fire like the size of Parry Sound 33. The region's quite humid, and we wouldn't anticipate fires of that size.
We wanted to understand how deep this fire burnt into the peat and see how much CO2 was released. There's still a lot to learn about these deep burning peat fires as we advance through a century where our planet may warm by 1 to 4 degrees Celsius. We also wanted to find out how reptile species habitat would be affected by this dramatic habitat change. The best way to reach this area is by canoe, so we planned our route down the Pickerel and French rivers. We packed up our things and headed out with all of our supplies and scientific instrumentation.
So since nesting habitat availability is already limited in this type of landscape, if we have fire come through and we lose any soil either to the fire itself or after the fire to the soil erosion, we could have hardly any soil left.
Vegetation normally holds soil in place, and without that vegetation there, the soil can be removed more easily by runoff.
And this can have really strong implications for the turtle population, because if you think about before, maybe turtles would be searching for a couple days looking for a suitable nest site. And then after the fire, when we have almost no soil remaining, it can be really challenging for turtles to find a site that's going to provide the thermal and moisture characteristics that those eggs need in order to incubate successfully. So we know that shallow soil deposits in a natural landscape can take hundreds of years for these soil deposits to accumulate. So if we were to just allow the landscape to naturally regenerate after fire, we would expect that it could take that long as well. So the idea would be in the short term to compare remnant soil depths in an area impacted by fire compared to an unburned landscape. And by doing this, this allows us to quantify the impact of the fire on the availability of nesting habitat. And then from there, we can start to begin to look at areas that we might want to try to restore, areas that might need additional soil in order for there to be deep enough sites for the turtles to potentially use.
Go a little lower. visited many peat wetlands and approximated the amount of CO2 released from the burn, as well as how and where these wetlands burned. Together, this will allow us to understand how they might recover.
You still do tend to see some of the really severely burned sites struggling a little bit. But one of the key elements that we're hoping to see is recovery of some of the key moss species that are essentially ecosystem engineers for a lot of these peatlands.
This peatland here we're in is about 2 meters deep, and what we see is large carpets of sphagnum moss. This hasn't even singed. It's been resistant to the fire, whereas we look around us, the entire landscape has burned, including the margin here, which burned to several tens of centimeters deep.
So some of the things that we've done to try to give the system a kickstart is to put back in some of those key mosses, which are the ecosystem engineers for peatlands. Some of the pilot projects that we started is basically taking small plugs from donor peatlands, inserting them into burned wetlands to try to get them to essentially kickstart the recovery process. And certainly controlling or trying to control the water balance of some of these systems with just some simple manipulations to make sure that water is retained in the system so that they have enough moisture to be able to sustain itself.
We believe it's really critical to start to create soil as quick as possible. We can't make mineral soil, but we can start to get organic soil accumulating on this landscape.
Well, it's exciting to be part of something that we can take our existing expertise and hopefully be able to potentially apply that to being able to remediate the landscape back to its natural beauty.
We exist in a time of rapid climate and landscape change. We must understand how fire has affected landscapes in the past, but know that we're moving into a period of unprecedented change. To respond, we must strive for two-eyed seeing, to see with one eye from indigenous ways of knowing and the other from Western ways of knowing. We have a lot to learn about fire and its effect on the landscape, and we're humbled by the tasks ahead.